Hey guys, welcome back to the next video. In this video, we are going to talk about ETCD. In this video, this is the first introduction video, the architecture video of ETCD. So which means that we are going to discuss a little bit depth inside the architecture of ETCD. But then talking about ETCD, brings up a conversation about the other services which you have as part of the namespace group system. Now, this is the default namespace. So if you remember, we have executed a command at the time of initializing the services for your Kubernetes stuff. So that time it just took a little bit of extra time because I told you that it is downloading the components which is required for the cluster. Because when we install Kubernetes, we install just the 3 commands. We didn't install the entire Kubernetes cluster or something like that. So when you initialize it, then it basically downloads these components, which is the kube system. So we just do kube control get namespace. So it configures these many namespace as default. And the one of the namespaces kube system. So this is where all your pods are running, which is related to your control plane. Now, most of them are running on the control plane itself, as you can see over here. Managers are the one which is mostly just running over here. So one of those is like the control manager. So I've put it on the graphical format over here. So the control manager, which basically, the core component of your Kubernetes control plane, it controls various processes or the states of these processes and manages those states as well. It's like it has a lot of controllers like node controller, replication, deployment, replica. So whatever the items we are seeing, like endpoints, namespace, persistent volumes, all these are controllers here, and these controllers are controlled by your control plane. Here, controller manager does that, and what it does is like it basically talks to your API. API manager over here. So this is your API server. I'm sorry, API server, which is over here, and that's basically sets up the kind. So whatever you do as a kind, you call this API server with the version, which is part of your API resourcing. So this is all works together. And when you execute any kind of a control, kube control and apply something like a YAML file, so it goes to control plane, API server, and ETCD is the one which actually notes down the stuff. Let's talk about ETCD in more detail because this is the whole hero of this particular session. As you can see here, I've just given you overview information about ETCD, and that's what we will focus on this from this moment onwards. So here is the ETCD server, or you can call it service as well. And this is a very much key value database or storage. So where it holds the values as in keys. So for example, I will be showing you how to configure these keys, and then I'll show you an example in another video in the session how to create your own key and then add a value and how to retrieve those values. So that also I will show you as part of this, this section. I'll also show you what is a split brain scenario because that has been discussed a lot on interviews as well. So I'll be explaining you about the split brain scenario, and I will be also giving you solutions and how to make the interviewer understand that you know what you mean. So that one, and then we will also see about a situation where we back up our configuration on ETCD, and then we will create a disaster scenario, and we will restore the configuration which we have just taken a backup. So those scenarios also I will discuss with you because these are very important for your exam as well as for interviews as well, because this is one of the far more difficult interview questions. And far more important high weightage in your questions as well in terms of your CKA exam. So one more thing you should understand is that this kube system uses host network, which means that it's going to use the network as this guy over here. It's going to use the local IP address of this guy in the kube system. So that's one of the important things that you should understand. And you can see that ETCD has client version installed already on your control plane or your manager host. Now, do remember that when I say client, it means just the commands. Yeah, there are three commands for ETCD. You have ETCD itself as a command, ETCD utils is another command, and then ETCD control. So ETCD control is more or less the one command which we're going to use the entire training. So you will see that we're using ETCD control everywhere. And also do remember that ETCD utils is like far more new command. It's available on the recent versions, and most of the options in ETCD utils has been transferred to. I'm sorry, ETCD control has been transferred to ETC utils, and you will see depreciation alert when we are using ETCD control. So there you will get to know that we may soon have to migrate certain options to ETCD util command. Well, anyways, going further down the line, so these pods are something which is created when you initialize your cluster creation, right? So one of those pods is ETCD. So now you will see this pod in action over here, ETCD Manager 1. Now, ETCD Manager is like, has all the configuration holding on this particular ETCD Manager. Now, this configuration is divided into two sections, I would say. One which is in the local manager, another one is hosted over here. So this pod is dedicated for working in close with other pods of yours, and then giving all those configuration there. But then at the same time, the same configuration levels will be holded down on this manager host or the control plane node as well in bad live etcd. So do remember that this is one place where your etcd server or service is holding all the contents over here. A disaster recovery scenario or disaster scenario, sorry, the disaster scenario is that you lose this particular folder. And if you lose this particular folder, you kind of lose everything about your Kubernetes. So we will create that scenario. And I'll lose this folder by removing it. And that time I will tell you how it actually looks like, your Kubernetes looks like. Then the important configuration file is this etcd.yaml file, which is in the manifest folder under your etc Kubernetes file. So this file is used to create the etcd pod, and it has very important information about etcd, which we will be make use of this while running our the client commands which we will use. So most of the items which was triggered on the client commands will be utilizing this particular YAML files, contents of this. Because this YAML file will have more details than what we actually know, because it's not possible for everyone to remember everything, service like a pod users, right? So that's the reason why they have kept it here, so that you can recollect what this particular service does. And these are the three commands I was talking about: etcd, etcd control, and etcd util. These are the three important client commands which you need to know to work with etcd. Now, you can work with these three commands within this pod itself. So you may ask me, I have the etcd pod, why should I even have the client commands here? Because I have the server itself, which has actually hosted over here. Now I can access this pod and I can work with it. Yeah, you can very much access this pod and work with it. But the problem is, like, the only three commands which will work on this pod is these three commands, which is over here. So which means even ls command doesn't work here, because it does not have those commands. So it becomes like practically impossible to work with this. But then if it's an internal component, it knows that it needs to call this command only, and it doesn't really look out for anything else. So it's not like really user friendly to work with it. But if your plans to have executing some commands just using these three options, then it's much better to work over here. But then do remember it's a pod, so which means that if you take a backup within this pod and you accidentally remove this pod, then obviously the backup will be gone as well. So it is also not recommended to work with this particular pod directly, but then to use the client commands to work it from your control plane node. Now, ETCD listens with two different port numbers over here. So one is called the client endpoint port number, which is 2379. Another one is the peer port number over here, which is 2380, the next port number. Now, what is the client port number? Port number is how you communicate from your ETCD client to the server. So now, if I wanna take a backup of this particular configuration file, so I use this endpoint port number and connect to this service, and then I take a backup on the local folder, local file, okay, on the manager node. If I want to restore the same, I still have to use the client endpoint port number, and then connect with the master and then restore the same. But what is peer port number? Peer port number is basically for connecting with another peer. For example, if you have another manager node for in a cluster environment and more high available environment for your manager node, in that scenario, you're gonna have ETCD on that particular manager node as well. Now, there's a situation that you have two ETCD nodes, but managing the same worker one and worker two, because you have two manager nodes. So now you need to define which ETCD is primary, as in master, and which ETCD is secondary, as in like slave. So which means that there will be no issue, and you can constantly sync the data between the ETCD, which is over here, to there. So it will act as a backup. What if both the ETCD declares itself as a leader? Then there is a problem. As we discussed, split brain scenario happens then, and then we need to do some activities to fix the split brain scenario. But you have to be very strict about which is going to be the leader and which is going to be. So I have commands for you to execute and check if it's really the split brain scenario and how to fix that split brain scenario. So that's pretty much we can discuss later point of time. So that's what I wanted to cover on this architecture diagram, more or less. So I think you had enough information. Let's go visit these files. Oh yeah, so this particular folder, right, the PKI folder. Now, PKI folder, as you know, that it will have the PKI information. So here you have a folder just for ETCD. So in this, you're gonna have multiple files over here. You're gonna have a peer key file and CRT file, which is used when it connects to the peer server. But we have not configured a peer server in the scenario, so we just have only one manager node over here. Okay, so the second one is like the client server.key and server.cert, which is used to connect to the ETC port. So whenever you are executing this ETCD command, you need to make sure that you mention about the service, the server key and the server certificate, so that it authenticates using the SSL method. So it is all using TLS authentication, so all communication from your client to the server. So it is mandatory that you execute the ETCD control command every single time, with including the server certificate, server key, and the CA-sign certificate, all available inside the ETC Kubernetes PKI ETCD folder. Because when you're connecting from the client to the server, it needs some kind of authentication. So we don't use username password anymore. We use the server certificates for communication. So this is something which you should understand before we proceed further. So saying all these items, so our commands is already part of the GitHub page, so which is already have given access to you guys. So you can copy paste the commands from there. Thank you again for your patience and time. On the next video, we will be discussing more about the hands-on towards how we're going to work on this ETCD. Thank you again for watching this video. I'll see you on the next one.